myself Dr. T. Sudarshan Rampamal. Today we are going to see about the distance vector routing. So in distance vector routing, the router continuously tells all of its neighbors what it knows about the whole internet. So in distance vector routing, Belford equation is used to find the least cost between the source node and the destination through some intermediate nodes. When a cost between the source and the intermediate nodes and the least cost between the intermediate nodes and the destinations are given. The distance vector routing, we want to update all existing least cost and at least cost through the intermediate node such as that is the intermediate node shorter. The equation how to calculate the minimum distance between the source and destination. The concept of distance vector is the reason for the same for the name distance vector routing. At least cost tree is a combination of the least cost path from the router of the tree to all destination. Figure shows a tree for node A in the internet figure and the corresponding distance vector. A distance vector does not given the path to the destination as the least cost tree does. It gives only the least cost of the destination. Each node in the internet, when it starts its function, creates a very basic distance vector with the minimum information a node can obtain from the neighborhood. This is a network shown below. Here we have the 7 nodes. The nodes are A, B, C, and D, E, F, and G. We give the cost of each node. From the given cost, we calculate the routing table of the each node. For node A, the routing table is 0 to infinity, 3, infinity, infinity, infinity. Infinity means there is no path, there is no direct path existing between the particular node and this corresponding node. Consider a node A thinks that it is not connected to node G because its corresponding cell shows that at least cost is infinite. To improve these vectors, the node in the internet need to help each other by exchanging the information. After each node has created its vector, it sends a copy of the vector to all its intermediate neighbors. After a node receives the distance vector from the neighbors, it updates the distance vector using Belford equations. By exchanging the vector, we can stabilize the system that allows all nodes to find the ultimate least cost between themselves and many other nodes. After updating node, it intermediately sends its update vector to all neighbors. So after updating, the infinity will be changing to the numbers. Advantages of distance vector. Distance routing protocol easy to implement in small network. Debugging